Jai Hind all of you. I am once again in front of you. I am Manish Kumar, Assistant Professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. So, today I am brief you about another complex topic of unit number 1, that is different approaches in machine learning. Different approaches of machine learning, we can say. So, before proceeding, I just want to elaborate you about the content today that I will cover. That is, first of all, I will fastly introduce you about what is machine learning, definition of machine learning, well posed learning problem, some examples of well defined learning problem, types of machine learning, and the today's focus is on introduction of machine learning approaches. So, what are the different approaches that I will brief you about, give you the brief introduction of ANN, artificial neural network, clustering, what is clustering, reinforcement learning, decision tree learning, Bayesian networks, support vector machine, and at last genetic algorithm. So, before proceeding, I will want to show you what is machine learning, what is the need of machine learning actually. As you all know that in my previous lectures also, I have briefed you that machine learning is a multidisciplinary subject, right? So, we will get flavors of all the subjects here. So, what we are going to do is, we are just going to train a machine. So, the question arises, what type of training we are going to do, how this machine will learn. So, the answer comes in our mind is that the machine will going to predict. And how it is going to predict? Actually, what happened, we will just give a training data to the machine, and that according to that training data, the machine will learn, and then afterward we will give the testing data. Then after giving the testing data, the machine will predict. So, this is how this machine learning concept works. Okay. So, what is machine learning? As you all know that machine learning is an application of AI, artificial intelligence. What is AI? It is a branch of science which deals with human intelligence. So, we are just make a machine intelligent enough to predict, to do predictions. Okay. So, it is a field of study that gives computer the ability to automatically learn. As I have said that AI is a science, branch of science. What branch of science? Where these machines will work as a intelligent system. So, I have written here ability to automatically learn. Okay. So, as intelligence requires knowledge, so it is necessary for the computers to acquire knowledge. So, we are just giving the intelligence to the machine. So, that machine will now going to predict. Okay. So, this is the definition that several times I have briefed you in my previous lectures, that it is basically based on these three concepts, that is the experience, E experience, T for task, and performance measure P. So, you will just keep in mind this TPE. So, this definition was taken from a book of Tom Mitchell, written in machine learning. So, he just said a computer program is said to learn from experience with respect to some class of task. We will assign some task, and the performance measure, how the task will perform. Accordingly, how that machine will learn from the experience. So, this TP is the main features that we have explained, we need to explain in this machine learning. Okay. So, yeah, you all are familiar with this diagram, that artificial intelligence is a superset, under it comes the machine learning. Machine learning is a subset of AI, and deep learning again it is a subset of machine learning. So, this diagram will just clear your concept. We are just dealing with here machine learning. So, what this machine learning is going to do? So, machine learning, we are just get a output, program as a output here, right? Yes, again one diagram. So, this is the ordinary system. So, with the help of artificial intelligence, we will implement some machine learning algorithm here, and this machine learning algorithm will output, it will learns, that the person will learn, and machine learning, with the help of this machine learning, we will do several predictions, and with the help of this machine learning, the performance will be improved. So, this is how I can explain the concept of machine learning, right? So, in machine learning, first of all, we must understand what is a concept of learning. We used to say every time learning. What learning? we are teaching someone? No, we are just giving a training to a machine so that the machine can predict for the future instances, right? So for that, how we can define a well posed learning problem? So again, based on that definition of machine learning that I have just explained, TPE, T for task, performance measure, P and E is the experience. So we have that well defined learning problem has three features. Okay, that is the class of task, number one. Again, this is the T, performance measure, measure of performance, that is P, right? And the source of experience, E. So on the basis of these three features, we can pose a learning problem. Pose means how we can going to represent the learning problem, right? So because as you know that what happens in our traditional programming? What happens in our traditional programming? Traditional programming. In this traditional programming, we will just give an input, right? And that input, what type of input? Some data will be inputted, right? Data input, okay? And we will write some program. I will write some program, right? And that traditional programming will give us the output, okay? And if I compare with this machine learning, in place of this traditional programming, I will replace it with machine learning. Definitely, we are going to input some data. Again, we are going to input some data here, right? And the one thing is that just I have said that we are going to train the machine. So training will be done to predict something because we know where my machine is going to implement, right? So and output will be given on which data the machine has to predict, right? And we will get a program, well trained program, and this program will predict. So this is the concept of machine learning that you all have to know. So for this concept of machine learning, we should know how we are going to pose that learning problem. Okay. So to pose that learning problem, these three important features, again T, P and E. Okay. So these are the examples from where you can know the concept. If for example, the problem is that checkers learning problem. So what is the task here? Task is playing checkers. P, performance. What is the performance measure? That how many percentage of games were won and against any arbitrary opponent. Okay. And experience is playing practice games against itself. Second problem, see, handwritten recognition problem. What is the problem here? We are going to recognize the written words. Okay. What is the performance measure? Percentage of words correctly classified. Okay. And what is the experience? The database of human labeled images of handwritten words. How many words are recognized? Okay. Again, another example, robot driving learning machine. So what is the task? The task is given here. For example, if we are going to drive that driverless car on a 4-lane highway. This is the task. Okay. What is the performance measure? Performance is the average distance traveled before a human judged error. Before coming any error, how much distance, average distance was before coming an error. How many sequence of images and steering commands are recorded, right? Yes, this you can also see. Email learning problem. What is the problem? What is the task here? Task is that we are going to categorize email as a spam or not a spam, right? What is the performance measure? How many percentage of email messages are correctly classified? On the basis of that, E is the experience. Experience means database of emails, some with human given labels, right? So there are several problems that we can discuss here also. For example, spam filtering problem is also there. You can also write the TP of this spam filtering problem. This is another example you can see. Okay. For example, in speech recognition, you can also make the TP of that speech recognition. Okay. Face recognition problem. Face recognition problem. This can also be defined. So first of all, before proceeding, we should know how to well define it, right? So this is the basic need. Then we are going to devise a system, learning system. Okay. See, so for the machine learning system, the three important features are: number one, the first important feature is that remember. Remember means a system must remember what it is learning. What is learning? For example, 2 plus 3 is equal to 5 at the age of 5. So this thing will remain remembered when a person is at age of 50 also. So he will also 2 plus 3 when he will add this. So on the basis of that, knowledge that he gained in at school level, so at the age of 50, what will be the answer? Answer will remain the same, 5. So number 1 is important feature is remember, to keep, remember. Second is adaptation, adapt. So adapt means the machine will going to adjust with new conditions. This is another feature. And third important feature is generalize. Generalize means allowing a system to make prediction on unknown data. Okay, this is called generalization. For example, I have seen the data. For example, 2 plus 3 is equal to 5. I have seen it. Again, another data is given. 10 plus 2 is equal to 12. I have seen the data. Then I will predict the new data. For example, I haven't seen this. So on the basis of my previous knowledge, I know how addition is done. So my answer will be 2 plus 2 is equal to 4. Right. So the same thing I was discussing, that this is my training data. So first of all, in machine learning algorithm, we will give the training data. Okay. So on the basis of that training, my machine will predict. That is called testing data, on the testing data. Right, students? So these are 3 features that a machine learning system must have: remember, adapt, and generalize. Okay. So now next comes the types of machine learning. Okay. We all know that the learning in machine learning is categorized basically into 3 types, that is supervised, unsupervised, and reinforcement learning. Supervised, unsupervised, and reinforcement learning. Okay. Supervised means under some supervision, right? So supervision, what we will say, that the learning is done under supervision of a teacher. Teacher is present here, right? We will provide input. Input is always there, and output is also there. We know that what type of output we are going to match. This is supervised. Okay. Unsupervised, here no teacher is present. Okay. Input is given, but we do not know what output is going to come. This is unsupervised. And reinforcement is a learning from where that agent, that machine will learn from its mistake. Okay. So I will just briefly elaborate you, explain you what happens here is. So it is written here, supervised means predict next year. We are going to predict the next level on the basis of the knowledge, right? Here unsupervised means data driven, on the basis of the data, because input is given, we do not know what output is going to come. That is identify clusters. Okay. And reinforcement means learn from mistakes, right? So from this chart you can elaborate what are the different under these learning, what are the different techniques that we will use. So under the supervised learning, we will do classification and regression. Classification means we are going to classify images, we are going to use it in machine translation. Regression means on continuous data. Regression is used for stock prediction, it is used for image masking, right? Unsupervised learning, machine learning and deep learning, it is divided into 2 parts. As I have seen before, I have know that this AI is the main superset. Under this AI comes the ML, machine learning, and under this comes the deep learning. Okay. Remember this diagram. So this unsupervised learning, ML, DL, machine learning, dimension reduction, clustering, what are different techniques, what are different algorithms that comes under which technique. So this chart will elaborate you that PCA, ISNEC, and K-mean, GMM, HMM, deep learning techniques, presentation learning, generative models, mutual. So this, as the subject progresses, you will come to know what different algorithms come under what technique, what learning. Okay. Machine learning, basically supervised and unsupervised. Supervised means we are going to develop a predictive model based on both input and output. Teacher is present here, input is there and output is there, right? Under this unsupervised learning, we will group and interpret data based only on input data. In unsupervised learning, only input data is there, right? So supervised learning is used for classification and regression purposes, and unsupervised learning is used for clustering. Okay. So as the name suggests, supervision, a teacher is present here. So the main is, and that is supervised learning, a learning in which we teach or train the machine using data which is well labeled. Here data is well labeled. It is under the presence of some supervisor as a teacher. Okay. So it is called as supervised learning, right? For example, we are given a basket filled with different kinds of fruit. Just try to understand how this supervised learning works. Okay. So for example, we are given with a basket where number of fruits were kept. Okay. Now the first step is I need to train the machine. Just I have previously said that we just give a training data. So training the machine means I will train a machine by using some size, by using the color, shape of that fruit that machine will recognize. Okay. So I will just train the machine. Okay. For example, fruit is given. So after that training, that shape of object is rounded. If the shape of the object is rounded and the depression at the top is that color is red, then this machine will predict, give that fruit a label apple, right? Secondly, if the shape of that object is long, curving, slender, having a color green, yellow, okay, then it will predict it as banana, right? So on the basis of this training, now suppose after training I have given a new separate fruit. Okay. For example, I have given a new separate fruit, banana, that is kept in a basket. So on the basis of the features of this fruit, for example, what feature? Color, shape. So that machine will predict and it will identify it. Okay. So this is how this training algorithm works. Okay. So since the machine has already learned the things from previous data, and this time we will use it wisely. So firstly, we will classify the fruit. How we will classify it? With the help of shape and color, right? With the shape and color, and then it will confirm that that fruit is banana, right? So this is how firstly we will give the training, and then the machine will learn and predict. Okay. So in that basket of fruit we have number of fruits, so we will apply that knowledge, and after applying that knowledge we will provide the test data. Test data means we are provide the new fruit, and on the basis of some features that fruit will be predicted. Okay, right? So types of supervised learning, it is classified, it is divided into two types. Number one is, as I have shown in a diagram, classification and regression. Classification means we are going to classify on the basis of some features, important features. For example, when the output variable is a category. Okay, category. For example, just I have seen in previous example, the fruit, the color of a fruit is red, or it is yellow or green. Okay, so this is the how we are going to classify the objects. Okay, so for example, red or blue, disease or no disease. So on the basis of this, classification is done. Okay, and what is regression? Regression means where the data is continuous, in continuous form. For example, when the output variable is a real valued output. For example, dollars and weight. The amount of money, weight, it is in real value. So when the real value is involved in the training and testing data, then we will use a concept of regression. Okay. So let me firstly elaborate you the difference between regression and classification. So in a classification problem, we just try to predict results in discrete output. Discrete output means yes or no, 1 or 0, true or false, right? And in regression problem, we are trying to predict results in continuous output. Okay, and that will be a real valued. Okay. So for example, I just show you with the help of an example what is regression and what is classification. For example, if a data is given about the size of house on the real estate, okay, in a market, so we are going to predict the price of the house. Okay. So price as a function of size, it is a continuous output. Okay. So price is in real value. Okay, real value output. So it is a regression problem. So this can be classified as a regression problem. Okay. For example, if I'm just going to turn this example into a classification. This is regression, and now how this example can be shown as a classification problem. So instead of making the output about whether the house sells for more or less than the asking price, I am not going to consider the price now. Now here I am going to classify the house based on the price into two discrete categories, that 1 BHK and 2 BHK, for example. So I have just classified on the two bases, 1 BHK and 2 BHK. Now this problem will become the classification problem. Before it is on the basis of the price, that is a regression, and now I have classified on the basis of the 1 BHK house or 2 BHK house. So now on the basis of this 1 BHK and 2 BHK, it is this example will now can be in terms of classification, right? So now next comes the unsupervised. Unsupervised learning is that where teacher is not present, that I have already explained you. So it is a learning technique where user do not need to supervise the model. Okay? Instead it allows the model to work on its own to discover pattern. Matlab that model will discover its own pattern and information that was previously undetected, right? And it mainly deals with the unlabeled data. In supervised learning, the data is labeled, and in unsupervised learning, we are dealing with unlabeled data, right? So this unsupervised learning algorithms will allow us to perform on more complex problems, more complex processing, right? Because output is not known, the data is unordered, it means the problem is become more complex here, right? So for example, as I have discussed the fruit basket example in supervised learning, here I just, in case of unsupervised, for example, we are given with the several images, okay, images of dogs and cats, which we haven't seen before, okay, for example, okay. Now machine has no idea now about the features of dogs, what are the features of dogs, what are the features of cats, on the basis of which it will differentiate. There is no idea, we can't categorize. So data is unlabeled, so we need to categorize it. For that, this machine learning technique is used. So on the basis of some pattern, on the basis of the color of the dog or cat, and on the basis of the ear size, on the basis of the tail. So what happened? We can categorize in on similarities, patterns, and differences. Okay, so by seeing the pictures, we can easily categorize it. So first contain all the pics having dogs in it, and second part may contain all the pics having cats in it. So here we didn't learn anything before, means no training data or example is given. Now after coming the images, the machine will predict on some similarities, on some pattern, and on some differences. It will differentiate between either the images of input images of dog or input image is of cat, right? Now next, types of supervised learning. There are, again, I have differentiated into two types. It is number one is clustering and number two is association. Number one is clustering and number two is association, right? So this is the technique used in unsupervised learning where we use a clustering. Clustering means we are divided into different groups. Clustering, that unstructured data is divided into groups in classes. Okay, that comes, this is unsupervised. Now here we will deal with finding a structure or pattern in the collection of uncategorized data. Okay, clustering means we are divided the data in groups. Okay, for example, just show you an example ki the dogs images will be separated from the cats images, right? Second is association. Association means we are going to relate something, associate something. Okay, so in this unsupervised learning technique, we are about to discover the existing relationships between variables in large database. Okay, for example, people that buy a new home most likely to buy a new furniture. So this is the association. The people who buy the new home most likely they will going to buy a new furniture. So this is the association. Okay, so we will discuss in coming lectures here also ki what are the different algorithms that we use for clustering and association. Okay, now third is the reinforcement learning. First is supervised, second is unsupervised, and third is reinforcement learning. Now this reinforcement learning, here an agent is present, okay, and it will perform some action. Action means for example, I just say you that for the examination purposes I am just going to I am studying very hard. I didn't get any guidance from any teacher. Okay, so what I will do, I just purchase some books from the market and study myself, seeing some sample papers and then study myself. And for example, if the result is fail, then I must see that there is some lack of preparation. So what next time then when I will go for exam, I will study hard, I will refer more material, right students? So this is how I will learn. It means I will learn from the environment, okay, and that pass or fail is the reward, right? So that is given, and again from that pass or failure I will learn how much effort I have to put for my next exam. Okay, this is the concept of reinforcement learning. Okay, so in this technique an agent will learn, okay, it will interact with environment by trial, okay, and if error feedback from its own actions and experiences, it will learn from its own actions. let me show you the diagram here. Yes, this is the diagram of reinforcement learning. An agent is present here. That agent will do some work and it will perform some action. Okay, and those actions will be given to the environment. Okay, and in this environment we will have some reward, pass or fail. Okay, that agent will learn from this reward. Okay, for example, my first state is fail. Okay, then I have to work hard. The reward is fail, so I will work hard again, perform some action, and now the output is reward is pass. Okay, this will, so these are the some terms that you will have to keep in mind in reinforcement learning: agent, action, environment, reward and states. Right, students? So agent, it is an important component to process the information, it is required. Okay, then environment is there. Environment is some real world or simulated world, okay, where the agent lives. State will give me the different configuration of the environment that the agent can sense. Okay, actions are what an agent does in its environment. Okay, so these actions are represented with different symbols. It can be represented as S, A or R in different books. Okay, rewards are positive or negative, as I have said. If an agent is pass, then it is a positive reward. If it fails, then it is a negative reward, true or false, right? So these are the some important components that are the part of reinforcement learning. Okay, so now this we have to focus on the different approaches. So I am just going to brief you about different approaches of machine learning now. Okay, so the first is artificial neural network. This is the some machine learning, first machine learning approach, that is ANN. So what is this ANN? Artificial neural network is a network which is inspired from the human brain, right? So here we will make some artificial, a word is artificial, na? So it is inspired from the human brain. In a human brain, millions and trillions of neurons were there. Okay, so inspiring from that biological neuron, we make a artificial neuron. Okay, so here the artificial neuron will given a new name called as processing elements, right? And those processing elements will do process. Okay, and layered by layered we will proceed and get an output, right, students? So it is a computational model that are inspired by the human brain, right? Information processing model that is inspired by the way biological nervous system works. How the biological nervous system works? For example, if I have held a hot cup of tea, then I will sense it is hot, right? Similarly, what happens? Some electrical signal is transferring from my hand to my brain. So that hot word is stored in my brain, in my neurons as experience. Okay, for next time if I hold a cup, I will just firstly check it is hot or cold. Okay, because that experience is stored in the neurons. In the same manner, this artificial neural network will work. Okay, so the neurons are the processing units here. In artificial neuron. Okay, so the neural network have the ability to learn by example, which makes them very flexible and powerful, right, students? So let me show you this is the basic operation of ANN, artificial neural network. X1, X2, so we will provide some input. Okay, what are these are the processing elements, and these processing elements are we are going to do summation. Summation means how many inputs are there. I is equal to 1 to n inputs are there, right? And x of I. Okay, and we will get some output y. Okay, so several terms are used here. See, and some we will use also here. Bias also is used here. Okay, see, bias is also used here. This is summation is done. Wij. W is the weight. Okay, this is that some threshold value is used to control that output. Okay, so this is the example that I want to show you, that for example, this is the input x1, x2, x3. Okay, these are the weights 0.2, 0.1, minus 0.3. So how we will get the output? We will just going to do the summation. Okay, this is the bias here. So bias is added here. Okay, to get the output, right, students? So there are several examples that we can show. Next is important is clustering. So this cluster analysis is used to do some grouping that I have said you. See, this is an example of clustering. So here we are given a data set where apples, cherries and pears are there. So what this machine learning algorithm will do, it will classify into 3 parts. ठीक है, this is the clustering. So these are some algorithms that will be used in clustering. ठीक है, partitioning clustering, density based clustering, distribution model based clustering, hierarchical clustering and fuzzy clustering. ठीक है, so these are several applications that we will use in my coming lectures. I will discuss you this in brief. Okay, now decision tree is another technique, supervised learning technique. You know from this tree, the term tree means we are just going to make a tree here. Okay, like this I'm just show you. See, tree is made here. For example, if I get an opportunity of getting a salary between this, then I will, whether I will join that job or not, it will depend on my condition of yes or no. I will check. If yes, I am going to join, I will check whether that office is near to my home. Okay, if that office is near to my home, then I will check whether that office is providing me a cab facility or not. Then I will accept that opportunity. Otherwise, no will be there. So like this, decision tree can be made. Okay, so in decision tree we will use these certain concepts here, information gain index, that I will discuss in the coming lectures. Okay, I will just next is Bayesian network. This type of network, Bayesian network, it is used on probabilistic graphical modeling. Probability means you all have studied about some a concept of Bayes theorem. That Bayes theorem concept is implemented here. This is the Bayes theorem. Okay, so it is a supervised learning algorithm. It is used for classification that is based on Bayes theorem. Okay, these are the posterior probability, prior probability, minor probability, that again I will discuss in the coming lectures in detail. Okay, so let me, yes, again another approach is called support vector machine, SVM. Okay, we know that we have already studied that supervised, unsupervised and reinforcement learning. So this support vector machine is a supervised learning technique that is used for classification and regression problems, right? So here in this support vector machine, we just divide different classes of that, different classes, the how it is divided. Okay, so this is done in this support vector machine. How we can differentiate, we can classify these two classes. One class is a circle, another is square, and how we will going to classify it. See, so I can classify, differentiate it with the help of this plane. This is decision boundary. Okay, last approach is genetic algorithm. So this word is come from the biological neuron, and this genetic algorithm is defined as a heuristic search algorithm. Okay, which is inspired from the Darwin's principle. What is the Darwin principle? You all know that everyone is trying to survive for its fittest. So see, this is the mechanism of genetic algorithm. All we must clear with this diagram. We will begin, initialize the population, evaluate the solution. If we will get the optimal solution, then it's okay. Otherwise, we will do these processes. This process is the concept of genetic algorithm. Okay, so in my coming lecture on genetic algorithm, I'll briefly describe this: selection, crossover, and mutation. Selection means we are going to select. Okay, crossover means for getting the new species, we will do crossover, and then mutation is done. Okay, so this is the new population that is used in the next iteration of the algorithm. New population will be generated. Okay, so these are the key terms in genetic algorithms. Again, I will discuss in detail in my genetic algorithm lecture. Okay, the main is that I just want to show you the approaches how we will proceed in machine learning. Okay, the chromosomes were used here, genomes, chromosomes in genetic algorithms. So what is here, we will consider it as a bit 0 1 0 1 1 in computer science. Okay, chromosomes represents, that is, the chromosome is a biological word, and in CS, in this genetic algorithm, we will consider a string which is 0 1 1 0, right? So fitness function is there, which will check whether I am getting the optimal solution or not, right? So this is the genetic algorithm pseudocode. Okay, we will firstly initialize the population, select the parent, recombine, mutate, and select the individual. Okay, these are some applications of the genetic algorithms here. So in my coming lectures, I will just brief you in detail. Okay, students. So thank you all of you.